Okay, so we've seen that SQL injection is a threat, so as an application developer, you might want to include a quick fix. You don't want to rewrite your entire application, so you add a filter to mitigate SQL injections. So a first thing we could do is, well, here we have quotation marks, so if somebody wants to do an SQL injection, he would have to use quotation marks in his exploit, obviously. So if there's a quotation mark in user supplied input, we just exit the program and just don't pass it to the database. Now, do you think this is a good idea? Well, no, it's not. It can be bypassed very easily. How could it be bypassed? Well, for example, we could set the user to a backslash and the password to or1 and then SQL comment. Well, that has the effect that this quotation mark will be escaped in the database. So it thinks, okay, the backslash quotation mark is an escape quotation mark. This doesn't end the string. This is a quotation mark that's within the string. So this entire part here will be treated as a string, even though it was supposed to be SQL code. Then comes another quotation mark. That's the quotation mark here from the password. So this is the string now. And afterwards, we can proceed with our normal SQL injection, because the password field was set to this. So this shows once again that filtering and blacklisting is really hard and usually not a good idea. So we don't want to do that ourselves. We use functions that the language provides. So there's a function, for example, called add slashes in PHP. What does this function do? Well, in everything that seems dangerous, it adds a slash in front. So if we have in the get parameter ID here, if we would as a user submit a quotation mark, add slashes function would put a slash in front of it so that the database knows that this is a quotation mark in a string and doesn't terminate a string. And then we could use it in the SQL statement, right? Well, not exactly. This exploit here would still work. Why would it work? Well, we can send arbitrary bytes if we URL encode them with this percent encoding, percent and then the byte value. Well, percent %bf, percent 27. Percent 27 is a quotation mark, just URL encoded. Percent %bf is just byte bf. So what this function would do now is to see, okay, there's a byte 27, because we're on bytes, that is a quotation mark. So it would write a byte value in front of it of the apostrophe, which is sorry, had to look that up, I'm really sorry. Here I just, because I've, to be honest, forgot what the hex value of backslash is, but it's 5C. You can check that with Python. So it would put a backslash in front of the quotation mark. But on a byte level, what it would have now is bf 5c 27. These are the bytes and it submits it to the database now. Well, unfortunately, if the database works on UTF-16, which some do, it would interpret this as one character. This is a Chinese sign here. So this here would be one character, Chinese sign, and then again there would be the apostrophe, which is bad because now we have Chinese sign, apostrophe, and then here we could put a space or true, and then we can use our normal SQL injection again. So some APIs, some functions are just designed terribly. But some functions that are especially meant for this are just also unintuitive. So there's a function called MySQL real escape string, which is exactly there to prevent SQL injections. So we pass the ID parameter into this function. We have a new ID value, and this we can use safely in our SQL statement, right? Because this function is supposed to escape everything dangerous. Well, why doesn't this work? Because here we use the ID value, it's an integer value without quotes around it. And because we can use an SQL, we can do an SQL injection that doesn't use any quotes or spaces or anything that could be escaped by this function. We can just use our techniques from earlier, for example, or true, avoid quotation marks, avoid backslashes, avoid all kinds of evil things, but still do an SQL injection. So this exploit here would still work. Well, now another thing you might do is, okay, we could just blacklist certain words like select or whatever, union, but also a very bad idea. As I've said many times, blacklists can usually be bypassed. Here we could use something like mid, password, is that. The same exploit we have used before, it doesn't use anything like union or select or whatever. And another point here is that some database systems do a Unicode downcast, for example Microsoft SQL Server. If you submit something like that, it will just do a Unicode downcast and replace these fancy Unicode characters with ASCII select. And then injection is possible again. So the only way really to mitigate SQL injections is to use prepared statements, because they use one connection for the SQL statement and then another connection for the parameters in the SQL statement, therefore separating code and data.